Hello and welcome to a new section on Intro to Software Protection. We are going to look at what is software protection, ESE packing, purpose, how to defeat software protection, what is unpacking, how to detect software protection, how to execute a packed ESE program, the standard process of unpacking an ESE, and some anti-debugging plugins. Software protection is a protection of software against piracy, overuse, and reverse engineering. And the two main ways to protect software is using anti-debugging, which is to prevent debuggers from attaching or analyzing. Or the second way is by packing, which is to compress the software whilst retaining its ability to execute. ESE packing is where the executable is compressed to a smaller size, and ESE protecting is where using anti-debugging techniques to prevent reversing. In reversing world, both packer and protector is commonly referred as packer. Examples of packers are UPX, AS Protect, Armadillo, VM Protect, etc. The purpose of packing ESE is to prevent reverse engineering, to extract the cracked license or serial key, and to defeat the static disassembly, or to make dynamic debugging more difficult. Packing ESE will also reduce the executable file size. How to defeat software protection? First method is to use unpacking. Unpacking is where you let the program uncompress itself into memory and then extract the original exe from memory and dump it into a new exe file. Then we will create a patch for the new exe. Another way is to use loaders. This is also known as runtime patching. Here, you patch the process in memory instead of patching the file. We use the loader to start the program and wait for it to uncompress itself into memory. The loader will then patch the process whilst it is still running in memory. What is unpacking? Unpacking is where you extract the original binary from the packed executable file. Automatic unpackers exist for popular packers, but may not work with different versions, and not also available for complex packers. And this also involves live debugging by defeating anti-debugging techniques. Detection of packer. There are packer detectors like PEID and DIE. These detectors can detect popular packers and also show the version of the packer. And there are also PE viewer tools like PE Editor and PE View. Two examples of screenshots of packer detectors: Detected Easy on the left and PEID on the right. This is the structure of the PE file. This is the structure before packing. We have the original entry point and program will start running here. After it has been packed, the original entry point and all the instructions here are compressed. And then the original entry point now is inside here. The packer will put a new entry point. So when the program runs, it will jump to the unpacker code, also known as a stub. And the packer code will then uncompress the packed original file into memory so that it becomes like this. Only then it will execute. So that is why we have difficulty patching the packed file, because the packed file is in a compressed state. And there are several types of packers. Type 1 is the simplest packer of all. An example is UPX. Type 2 contains multiple packing layers. Type 3 is similar to Type 2, but here it involves more complex structures like loops and also different codes like integrity checks, anti-debugging, and so on. Example would be PE Compact, AS Pack, AS Protect, NS Pack, and so on. Type 4 packer is either single or multi-layer packer, in which a portion of the packer code not responsible for unpacking is interleaved with the execution of the original program. An example is ACP Protect. Type 5 packer is an interleaved packer with the unpacking code interleaved with the original program. Example is Beria. Type 6 packer, most complex type where the unpacker unpacks fragments of the code at any given time during the execution. An example is Armadillo. Type cell unpacker is where virtualization is being used on instruction translation to avoid the original code from being exposed in the memory. Examples are Tamida and vmprotect. The execution of a pack program is like this. Execution will start from the new OEP, which is the OEP of the stub or the unpacker, and then it will push the EBP and some of the registers to the stack. Then all the pack sections are unpacked in memory. Then it will resolve the import address table or IAT of the original executable file. IAT is the list of dynamic link libraries which is being used by the program. It will restore the original register status using pop-add instruction or pop-EBP instruction, and then finally it will jump to the OEP to begin the actual execution. A single push AD instruction is equivalent to all these pushes. The most important is EBP. A single pop-add instruction is equivalent to all these instructions, and the most important is pop-EBP. Pop-EBP is the way we can track when the packer is about to return instruction to the extracted exe file. Now this is what it looks like when the packer is about to return instruction to the unpacked file. When the program first starts, it will start with the instruction for the packer. Before the packer starts, it will push EBP to the stack so that it can return to it once it has extracted the original exe file. And then just before it goes to the extracted file to execute it, it will pop EBP. So this is how we can make use of this characteristic to track when the unpacker has finished unpacking and is about to return to the extracted exe to execute. We can put a hardware breakpoint on EBP. Now the standard process of unpacking exe is like this. We will debug the exe to find the real OEP, and then once we found it, you dump the fully unpacked program to disk. Then you fix the import table, and if necessary, also the P header. Now unpacking using x64dbg. First we load the packed exe into x64dbg. Then we start tracing the exe until you encounter a push AD or push EBP instruction. Then you put a hardware breakpoint on the EBP address in the stack. Next, you press F9 to continue the execution. You will break on the instruction which is immediately after the pop-add or on pop-EBP instruction. Then you press F7 to start tracing, and soon you will encounter a jump instruction which will jump to the original entry point in the original program. Once you have found that, at the OEP you can dump the whole program using x64dbg Skila plugin. So dumping is a process of extracting the original exe file and saving it into a separate file. After you have done that, you need to fix the import address table so that the new exe file will know where to look for the DLL libraries that it needs. There are also anti-debugging plugins. Anti-debugging is where the software itself detects that debugger is attached and therefore will refuse to execute. And there are two very popular plugins which can defeat this anti-debugging. That's all. Thank you for this lesson. In the next lessons, we will start our practicals. See you then.